Hi guys, now let us look at this example 2 on evaluating the derivative of the log functions. Guys, in this case you can already see that this is the natural log of a ratio, right? So again, one can, like this, there's few more than one ways of doing it. One can just directly use the idea of the chain rule here. Of course, one has to keep in mind that we have to go back and use the basic definition. What is the derivative of any function of the form ln of x, which is 1 over x, and then you got to multiply by the derivative of the inner. So guys, we can just directly use that and start writing the derivative. Or if we want to make life a little bit easier for us, what we can do is we can first go back and see if we can use any of the basic log properties. And guys, looking at this guy right here, it seems like we have a log of a ratio, which is like of the form log of m over n. And if I look at this particular property of log, it says that if I have a log of a ratio, we can break it down as the log of m minus log of n. So we can first rewrite this as ln of 3x plus 1 minus ln of 4x minus 2. And that is going to make our life so much easier once we start finding or writing the derivative of these two particular functions. Again, guys, yes, you can start right away without using the properties, but using the property makes it so much easier for us. So if it's making life easier, why not use it? Okay. And again, these properties are something that you are supposed to know. And in case we forget these, that's fine, guys. We can go back and review it. They are not too complicated, right? So now let us go ahead and write the derivative. So let us call this y function, and to write the derivative of y, first I have to write the derivative of this and also the derivative of this as well. Writing the derivative of this, we know, again, we have to use the idea of the chain rule. It is still the inverse, 1 over 3x plus 1, but you cannot just stop right there. You got to multiply by the derivative of the inner, and the derivative of this guy is just simply 3. And then this same thing, 1 over 4x minus 2, you got to inverse that, and then times the derivative of the inner, which is in this case just simply 4. Simplifying further, guys, this is going to be 3 over 3x plus 1, and this is minus 4 over 4x minus 2. Guys, you can stop right here, but if the answer is slightly different than this, then sometimes what they like to do is they like to create the common denominator so that they can combine the numerators. And I mean, you can multiply this guy by 4x minus 2 and this by 3x plus 1 and then combine those. I'm not going to do it right here, but if you want, you can do it. But if you leave the final answer like this, that should be fine as well. So guys, you can see that this is a log function. It's a quotient here. So one can use the property, and then it becomes easier for us to write the final derivative of the function. Guys, example 2 is done. I will see you next time with another example. Till then, take care.